All right. I would say let's get started with that talk, since we just got 40 minutes and a lot of stuff to cover. What do I want to talk about? I want to combine two perspectives for sociotechnical architectures. One perspective comes from domain-driven design, that's the context mapping stuff. And the other perspective comes from the book Team Topologies, which came out, I think, 2019, and was written by Matthew Skelton and Manuel Pace. And I think both approaches are great on their own, but they can perfectly be combined together to get even better insights into socio-technical architectures and dynamics. So just a few words about myself. I'm Michael. I'm a fellow at a consulting company called InnoQ, and very often I consult around domain-driven design, team topology stuff. I wrote a few articles and books, and recently I translated Team Topologies to German for O'Reilly. So let's jump right into some of the team topologies stuff. A good quote from the book by Matthew and Manuel was, as an architect, you should be thinking which team interaction modes are appropriate for those two teams. What kind of communication do we need between these two parts of a system, between these two teams? And what we already see from this quote here is that these approaches have a very holistic view on the engineering of systems. So on the one hand, we have a business system, a domain system. We may have a technical system at hand that manifests itself in building blocks of a software architecture. But there is also an organizational ecosystem that builds these systems. And what we should be doing is to have a very holistic view on these things and on the dynamics. So some basic ideas, where I'm connecting the dots from in this talk, come from an idea that we have an architecture that we want, which should be a model of the business domain. So it should be structured in a way that is compatible with the views of domain owners, of domain experts, of business people. But we should have a certain alignment on the organizational side as well. Obviously, I'm talking quite a bit about ideas behind Conway's Law here, for instance. So if you have a back-end team, a database team, and a front-end team, and you tell those folks, hey, please go ahead and build a mortgage loan selling system. What building blocks are these folks going to build you? A front-end, a back-end, and a database. If you tell them, build us an e-commerce site, what are they going to build you? A front-end, a back-end, and a database. If you tell them, please build a fitness tracking application, what are they going to build you? A front-end, a back-end, and a database. Because that's the way how they communicate, that's their skills, and so on. But is that a suitable system structure if you want to move fast in the future? Probably not, because for every change, these three teams need to coordinate their efforts. First of all, the front-end team goes to the back-end. Oh, we need those new fields on the API, and so on. Then the back-end team says, oh, okay, great. We'll do that in our sprint planning. They go to the database team and tell them, hey, we need those new tables, these new fields, maybe that persistent view. Can you build that for us? Yeah, sure. Let's put that into our sprint planning. So the database sprint runs, the backend sprint runs, the front-end sprint runs. So basically 6 weeks of time lost. Yeah, that's so. And there is a discipline which I would consider isn't so new actually, but I think the gathering of attention, the awareness in the community is rather new, and that's called sociotechnical architecture. A good friend of mine, Eduardo da Silva, who writes an awesome blog post, and who's also an amazing speaker and a really good thinker about these things. He had a really good quote and said, sociotechnical architecture is about taking a holistic co-design approach to technical and organizational systems, given the inherent impact they have on each other. What we want to achieve there is autonomy, mastery, and purpose. So teams should be loosely coupled. They should be able to master certain pieces of a domain, and they should have a very clear purpose. So what we need in that area are good boundaries. Like Robert Frost said, good fences make good neighbors. Yeah. So we need good boundaries in which teams can achieve autonomy, mastery, and purpose. And a very prominent example for that comes from the domain-driven design space in the form of bounded contexts. Yeah. So that is something. So when I recently do DDD consulting with customers and domain modeling with them, I very often do that with a very strong organizational perspective. Hey, let's find boundaries, not just for modules in software, but also for future teams. And within these boundaries, I want to make sure that the cognitive load of the folks working in that boundary, of the cognitive load of the people in that team is okay. Yeah, so are they able to master and learn the complexity of the domain? Are they able to conduct experiments, to learn in there, to develop these things further? Yeah, and not just to have a minimum maintenance like fixing Log4j security issues or stuff like that. Yeah, it's like emergency fixes. And are they still able to deliver high-value software? Please keep that in mind, especially when you're dealing with teams working on legacy software. I worked with countless teams and asked them, hey, what's the purpose of your team? Well, to keep this thing alive is a very widespread answer. So are you actually able to understand all the complexity in there? And they were laughing at me like, Michael, that's a good joke. Are you able to deliver high-value software? Hell no, we're just doing quick hacks all the time. And things get worse, 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 worse. Yeah, so please keep that in mind. That is very important. Yeah. So we talked about purpose and mastery a bit, not so much about the autonomy. And this is where I want to introduce you to a discipline that I consider to be, where I consider myself to be a learner, a heavy learner, and I think I will be an eternal learner in that area. That's called systems thinking. Systems thinking is very much about having a very holistic view on a system. And with system, I wouldn't necessarily see only an IT system. I also see the organization building that system as a system. The environment in which the teams operate a system. Yeah, there can, for instance, be certain blockers, like a crappy developer experience. Like last week, I talked to a team and they said, Michael, when in the banking industry, which is heavily regulated, and they said to me, Michael, when we need a new production database, we need to fill out 5 forms, and it takes 6 months to get that database, if we're lucky. So there is a certain blocker to that. I mean, try to introduce a microservices architecture into that system. Will you be able to leverage the advantages of a microservices architecture in such an environment? No, you won't. Yeah? You can say, yeah, microservices, time to market. Ooh. Well, not so much time to market, because database in production takes 6 months, if you're lucky. So please have a holistic perspective on that. And I think we need techniques to manage that, yeah, to visualize these dynamics. And I'm not so much a fan of this term autonomy, actually, because first of all, there is a certain, especially in the German market, a clash. I'm from Germany, so that's why I bring up German examples. So autonomy in Germany, yeah, so some managers see black bloc, left-wing radical folks with Molotov cocktails in their hands. Because the Autonomen, yeah, the autonomous ones, are extreme folks at demonstrations who are causing havoc all the time. Yeah, so when I talk about team autonomy, I had quite a few managers who were like, oh, We don't want that. So, and also it doesn't imply that the teams can do whatever they want when I talk about team autonomy. Yeah, I had an insurance customer, and one of the managers said to me, Michael, hey, if the team is autonomous, they could decide to start developing mobile games instead of insurance stuff. I said, no. When I talk about autonomy, I want to talk about loose coupling between teams. Yeah, like reducing the need for interactions between teams. Yeah, there is no decoupling in software. Decoupled software is one island doing one thing, another island doing another thing. How can these serve a greater cause? It's impossible. We talk about loose coupling for a very good reason. And we should do that for sociotechnical systems as well. Now, one approach to that is team topologies. And team topologies is, first of all, an evolutionary approach. And it's not like, okay, you define an organization and it stays like that forever. That's totally against the idea of team topologies. You want to evolve your organization and the interaction modes between teams. And there are two very, very prominent building blocks with team topologies. One building blocks are the fundamental team topologies. So there are basically 4 types of teams in an organization. And the team topologies folks say these team types should work like magnets. So one team should be, each team should be attracted to one certain magnet. Yeah, so they should tend to be a complicated subsystem team, an enabling team, maybe a stream-aligned team, or a platform team. And a very strong focus in team topologies is on the stream-aligned teams. Stream-aligned teams are usually teams that work in your core domains, yeah, where you really want to differentiate yourself, where you want to work really fast. And a lot of the team topologies works targets at making these folks fast in their delivery. Yeah, so they usually work on a certain business problem, on a certain organizational capability, and usually, very often, in customer-facing stuff, or stuff that customers may indirectly also see, but they see a severe impact of that stuff. So, for instance, yeah, what was the key differentiator of PayPal back in the days? Was it the app? Was it the UI? No. It was their clearing system that enabled them to move money really fast. Yeah, so that I'm in a bar with a bunch of friends, we had a few drinks, and I say, I get 20 euros from you, 30 euros from you, and I pay the whole tab. And everyone PayPals me the money, and when we leave the door of the bar, everything is settled. Yeah? The clearing system was the enabler for that. They probably had something like that, for instance. So the other team types very strongly aim to support these folks, to reduce their cognitive load. So for instance, a complicated subsystem team very heavily targets on skill sets that are hard to find and recruit on the market. I'm pretty sure that applies currently to a lot of the AI machine learning stuff. Yeah, I mean, good AI ML experts are rare. Yeah, so I saw that from my stepdaughter. She studied that, and the amount of offers that she got after she completed her master was crazy. Yeah, so you maybe want to bundle these skills that solve very complex problems, that learn for the organization in that area, and provide a service to the others. Should you stay with a complicated subsystem team forever? No. Maybe, yeah. You learn in there, you figure out what's going on, you solve some complex problems, you gain experience, and then we move some of them towards a platform team, that we offer a platform to others on which they can build upon. But don't mix up platform in terms of just having a continuous delivery CI/CD DevOps platform, a technical platform. That can also be a business platform. Think about sending and receiving letters, scoring credits or whatever. That can also be business platforms. And a platform team is doing a good job when they are surprised what great stuff the stream-aligned teams are building on top of that platform. Yeah? The platform team also is heavily targeted at reducing the cognitive load of the stream-aligned teams. So, hey, you don't need to bother operating Kubernetes, for instance, or Cloud Foundry or something like that, or something else. Hey, there's the platform. You can just use it. There's a very clear contract. It's self-service, and so on. So there is a low entrance barrier, easy to learn, easy to use. You don't need to bother with that, your stream-aligned team. You just use that as a service. And another team is the enabling team. I think the enabling team is the most underrated team type in that area of them all. It aims to enable other teams to do certain things, like agile coaching, site reliability engineering, domain modeling, collaborative modeling, software architecture work. So, for instance, if you're in a legacy, hello? If you're in a legacy system and you transform, you have your ivory tower architecture teams, for instance. There are smart folks in those teams. They are really good. They are very seasoned and experienced architects. But when you want to move this stuff to an agile delivery model, well, what do we do with them? We don't want to have teams like that sit in an ivory towers and tell others what to do. We want to move a lot of the architecture work into those teams. So maybe architecture enabling teams are also a good idea. In complex transformations, where a cultural shift very often goes hand in hand, I worked with customers and established management enabling teams that enabled managers to let loose, to trust teams, yeah, to move decision-making competencies into the teams. How should managers act in an agile delivery system? Yeah? There is a lot of fear among these people, and they're not stupid for that. I mean, it's their jobs. Yeah. So I had quite a few middle managers that said, Michael, where's my role in that? I don't say myself, will I get fired if I support that? Well, I think you need to support those folks because they are the decision makers. And another thing is team interaction modes. Team Topologies knows 3 team interaction modes. Collaboration means 2 teams collaborate a lot together. So if I pick this young gentleman here, we sit together and we sit a lot in meetings. Maybe we include you and you as well. We coordinate our efforts. We talk to each other. We spend a lot of time in meetings. You may think, oh, that's not a great idea, because team coordination takes time. It's not black and white. Coordination enables you to decide fast. Yeah? Hey, let's sit together and figure things out. After that, we define a contract, and we don't need any more coordination. So collaboration is something that you want to have only for a certain amount of time in that delivery model. Acts as a service, on the other hand, is, hey, I provide a service, and you can use it however you want. So, for instance, I'm currently provide a service. I conduct a talk. There is a clear contract. You need to move your body into that room. It's self-service, and you just grab a seat and sit down. I mean, if you want to stand, fair enough. That's the contract. Do you need to collaborate with me for attending the talk? No. Did you need to sit in a meeting with the awesome organizers at Øredev? Props to them. No. They had a self-service platform on which you bought your tickets. No need for collaboration. That would scale really horribly for the Øredev folks if they needed to collaborate with every single person buying a ticket. And then we have facilitating, which is obviously targeted at the enabling teams so that they facilitate with other teams. And Team Topologies visualizes these things like that. Good stuff. I like that a lot because it's simple, easy to understand, and especially easy to communicate to others. But, of course, is it the holy grail that solves all of your problems perfectly? No, absolutely not. By no means. That's rather simplistic, and it's sometimes missing a few details. And I say that as a Team Topologies fanboy and as the translator of the book into German language. There are a few things that are a little bit shallow in that area. For a very good reason, that's totally fine. That doesn't make it bad or lousy or superficial or anything at all. But we can dive deeper. So Team Topologies allows you to dive deeper, and Matthew Emanuel explicitly encourage you to do that. Yeah. So one thing, yeah, when they talk about identifying team boundaries, especially for stream-aligned teams, they talk about so-called fracture planes. And they discussed a bunch of those in their books, like technology, like quality requirements, like do we have certain areas that need to be super scalable, others that don't need that be that scalable, areas that need to be super available, or others that don't need to be available. Look at a typical in-house business application. Availability from 6 a.m. to 8 p.m. is good enough. Good enough is always a good idea for any software architectural work. Yeah. Now, one more thing that they have added is that they said the DDD bounded context is a team first boundary, that it's super suitable. Do you see me connecting the dot to the intro of the talk right now? Yeah, so that's also pitched by the Team Topologies folks. So what I do in my practical day-to-day work with these things, I start with bounded context, and there are always areas where things are, where you aren't sure. You say, it's a trade-off. And after that, I break off into the other fracture planes. So I start always with bounded context, and then I look into regulatory requirements, performance issues, quality requirements, technologies, and all the other fracture planes that are out there. Now, nevertheless, Team Topologies has a team-first approach. It looks at teams first. Yeah, so Team Topologies covers some stuff like team collaboration, teams collaboration, services, enabling teams, team boundaries first, and so on. On the other hand, strategic DDD has something that is 20 years old. Team Topologies is young. Context maps and strategic DDD are 20 years old. This is no bleeding edge stuff. Maybe the popularity may be new, but this has been in the book for 20 years. And context maps have a similar perspective with some differences. So first of all, they look into bounded context first. And if you want to get a good overview about all things context mapping, we don't have the time to dig into the details. So at DDD conferences, I sometimes do 90-minute deep dive talks where I only talk about context maps, and I could talk a day about that stuff. So we have 10 minutes. If you want to dig deep, there is a site on the internet, on GitHub, called DDD Crew, with a sub-project called Context Mapping. And there is a cheat sheet, a Miro board as a starter, and everything under a Creative Commons license. So basically, that's an open source resource for you folks that you can download, where you can get started with that. And it's a community effort. So let's get started with some of the patterns. One pattern, for instance, for a context map is something called an open host service. So you have a system or a bounded context, and it offers its functionality, its capabilities through a service. That's very similar to the X as a service team relationship, but on a system level now. But there's one thing, that services is targeted at many consumers. Think about the Google Maps API. Google Maps API is targeted at everyone out there. Yeah? There is no Volkswagen Google Maps API, a Tesla Google Maps API, and a General Motors Google Maps API, and a Volvo or Polestar Google Maps API. No. There's one Google Maps API for everyone, and it's the same. Usually, we visualize that with OHS. Yeah? Context maps also deliver you a visual language for that. It's a bracket called OHS, and teams providing an open host service are usually upstream teams. They're very powerful. They own that stuff. When they change something, everyone else needs to conduct changes accordingly. Now, usually, we offer a model through that API. Yeah, think about data being moved. So I go to, let's say I go to the Google Maps API and tell me, how do I get from this convention center here to the airport in Copenhagen? So I did that the other way around 2 days ago. And they delivered me a route and proposals for public transport. They told me there's this train, it starts there, and maybe 30 minutes later, and that has a certain data structure. There is a certain model that the API delivered. Now, think about yourself being a consumer on that thing. One thing that you can do is that you take that upstream model that's coming and transform it to your own model. That's called the anti-corruption layer. So basically, we do a model-to-model transformation. It means, in terms of coupling, that the heart of the consuming system stays the same. Yeah, the domain model in the consuming system is untouched. But there is something outside of that that's taking in the external model and transforms it to your model of the consumer side. Loose coupling. Yeah, so the coupling doesn't go as deep as the heart of the consuming system. On the other hand, the conformist has a higher degree of coupling. Yeah, so that means when this is the model of the open host service, it's the same in the consuming system. On an own code base, yes, but it's structurally the same. It follows the same semantics. Yeah? The modeling goes deeper. You may now think conformist is an anti-pattern. No, it isn't. It's a fair trade-off decision. Conformists are easy. They're super fast to implement. You don't need to think a lot about them, but you're a little more coupled to the other thing. In certain situations, that is a totally fair enough option. I have built a bunch of conformists, and I am still super happy with them. They were good design decisions. Whereas, on the other hand, I had situations where I built anti-corruption layers, and they were the better decision. It depends, as always. Now, another thing is customer supplier. Usually, the team with an open host service has the power. Yeah? And you don't want a lot of influence on others against your open host services. But sometimes teams need to have a certain degree of influence. So we give them that right. This is not a technical pattern. That's a governance organizational pattern. Where we say, hey, for instance, a team scoring credits must have the right, for instance, in a mortgage loan system, to tell the folks who implement the application form, where people fill out the application form for the mortgage loan, to tell them, hey, listen, in order for us to be able to do the scoring, we need the following information. Please make sure that this stuff is in the form, because there's no other way for us to gather that. Yeah? So we give them a little bit of an influence over the other team. That's called customer supplier development. Yeah? With context maps, you can visualize different perspectives. You can visualize call relationships between teams. That's a very, very popular relationship between systems. Oh, they are using that API, and they're pulling in those events and are reacting based on them. We can have visualizations for team relationships on a first level, upstream, downstream, mutual dependency, for instance. We can have an API level that we can visualize in context maps. We can dig deeper into that. And this is something very unique about context mapping. You can take a closer look at coupling by seeing how certain models propagate in a system. Let's say you have a chain of conformists. One system conforms to the other. They're connected to another system, which also conforms, which also conforms. When you change something in the first system, the change may propagate to the fifth system without them being directly connected. Yeah, those are the nasty coupling things that you can visualize with context maps. And you can even take a deeper look at team relationships. And there are many more patterns that address various aspects, yeah, like team relationships, model propagation, API, technical stuff, and so on. So compared to team topologies, context maps have similarities with them, yeah, like teams, collaboration, services, interfaces, but they also take a look at these relationships from different perspectives. They take a look how do domain models propagate. How about governance? Team topologies doesn't talk a lot about governance. Context maps explicitly talk about governance, about team dependencies, about organizational solutions. Yeah, there is separate ways, for instance, as a pattern where we can say, okay, we do that part on paper, for instance. Yeah, and it's about context boundaries first, not team boundaries first. That's what context maps are. Now, to wrap this talk up, I want to send a key message. Yes, you can both combine team topologies and context maps together. That works perfectly. Let me give you some examples. First example, we have this stream-aligned team. That looks nice, doesn't it? But how aligned is that team really? Let's dig deep. So we have two bounded contexts with an open host service, a conformist, and an upstream-downstream relationship, and that's the responsibility of that team. I would say that's a not so stream-aligned team. Yeah? I wouldn't want to have that, for instance, in a core domain where business differentiation and moving fast is super important to me. Well, that would be better. That's extremely aligned. Yeah? But mind, yeah, I think this still can be okay. Yeah? It's not a black and white thing. But please, in this scenario, mind the cognitive load of that team. Are they able to manage and learn the complexity in there? Are they able to deliver high quality software? Are they able to learn and evolve that stuff further? If you answer all of that with yes, it's good enough. Yeah? It's not black and white. It's about it depends and being good enough. How complicated is the responsibility of a complicated subsystem and team? I think that's really complicated here. Yeah? So learning, yeah, you can evaluate team types. Yeah? Is that stream-aligned? Is that a complicated subsystem team? And so on. But also, on the team interaction modes, we can do a deep dive. Let's grab an example. Yeah? We have an X as a service relationship between a complicated subsystem team, which provides a service, to a stream-aligned team. How does that relationship look on the inside? Let's add context maps to that. Yeah, so, okay, we have a bunch of bounded context. One provides an open host service, and we have an anti-corruption layer on that. I think that's a very nice X as a service relationship between the teams. Other examples can also be seen for platforms. Yeah? But please be aware, there is a certain danger, especially to the first part here. We have a customer-supplier relationship against the platform. Usually, a platform team should be like an internal product team. They should act like a product team. They should treat the platform as a product, but the customers are only internal. Yeah? Sometimes having a customer-supplier relationship on that can be okay, but you run the risk that this is very, very quickly moving away from an X as a service relationship towards a collaboration relationship that can be okay for a certain amount of time to figure out certain parts of the platform, but you wouldn't want to have that forever. Yeah? Sooner or later, you want to get rid of that customer-supplier thing here. Yeah? So that can be a warning sign. Yeah? If it's temporal, cool. Yeah? Or how does the collaboration look in detail? Oh, we have a shared kernel with a partnership between the two. To be honest, that's something you don't want to have, because these teams are bound together forever. Yeah? It's really hard to split that up. And basically, you run the risk of merging these things. You need to be very aware of that. That can be okay in certain generic areas where you say, that's not so important for us, that's okay. But in areas where you have core competencies and where you want to really move fast and where you really want to differentiate yourself, where you really want to make sure that this streamlined team can move independently and fast and deliver customer value in a quick fashion, you want to get rid of that, because this relationship is a really major blocker for that team. Yeah? So this is something where I would think that I would want to get rid of that very easily. What could be a solution for that? Does anyone have an idea? How about having a vision that we replace this on the Team Topologies side through an X as a service relationship? Sooner or later, let's target, I would say, when you start with these things, start on the Team Topologies side. So maybe a target can be establishing an X as a service relationship between the teams. Now, on the inside, what we need to do, I think we could use that shared kernel in the partnership with the collaboration to figure out how an open host service on the bounded context on the complicated subsystem team side could look like. Like collaborate to figure out how that can look like, and then move the shared kernel away towards an open host service. And as a first step, establish a conformist on the streamlined team. So you're getting rid, you're moving towards an X as a service relationship here. And then as a next step, maybe even go further and establish an anti-corruption layer on the consumer side. So you can see by me discussing these things, this is an evolutionary model. This is not about, this is wrong, this is right, you're doing a good job, you're doing a bad job. No, it can be a means to visualize an evolution of a sociotechnical system at a very substantial way, that digs deep, where you really can see interdependencies from various perspectives in that area. And I think this is what all the systems thinking stuff is actually about, having a holistic view, a holistic understanding of a system as a whole, and especially with the dynamics in that system. Dynamics on a IT system perspective, but also dynamics on an organizational perspective. And that's what you want to achieve there, and that is achievable with these things. So to wrap up my talk, we have 10 minutes of time for discussions. No. We have 3 minutes of time. But one hint, if you're interested in that, the Team Topologies folks have published a mini book, which is free for download. Under that address, I think it costs you your email address. And there is an article by me in there about the very topic of this talk. So if you want to read that as an article, and I think there are also former speakers of Øredev involved. I think you at least had Nick Tune last year. Susanne is awesome. I always say I'm the chief of the Susanne Kaiser fan club. She's amazing. And so you may want to download that. And let's switch to the questions. Does anyone have some questions? Yeah. Yeah. Yeah.
But there are places where you want it. So that question for you is, where did you start? First make that decision you don't want to. What were the premises that got you to that statement?
The streamlined team is the reason why I don't want this. A streamlined team should be able to move fast in an independent fashion.
Okay, so you first defined that.
Yeah. Yeah, exactly. Yeah, exactly. Yeah. Totally fair enough, but I would want to avoid this in the context of streamlined teams, because the target of that team type is move fast, be quick. Yeah. One further question. I'll be around for, I think, another hour roughly at the conference. After that, I need to head to the airport. First of all, thank you very much for having me. It was a pleasure at Øredev. Yesterday was awesome. Today was great as well. Thanks for having me. I feel blessed. You can contact me over any social channels. Follow me wherever you want. And if you have any further question, meet me in the hallway track, which is always valuable at any conference. Thank you very much.